Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing computer aided software engineering tools. Learning objectives: outline the difference between classic and real computer aided software engineering tools, discuss how computer aided software engineering tools contribute to software quality assurance, outline the pros and cons of computer aided software engineering tools. Major content of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. Introduction: computer aided software engineering is a term covering a whole range of tools and methods that support software system development. Already we have discussed the phases in the software development life cycle. Analysis phase, where the deliverable is a software requirement specification document, which is a legal contract between the client and the developer. The design phase, where we have architectural design and detailed design. The coding phase, where the design is converted into programs. Testing phase, deployment phase, and the maintenance phase. Case tools and methods reduce the load on developers, allowing them to focus their skills on other goals. Case tools are usable at all stages of the software development life cycle. The core is the case repository. We have analysis tools, drawing tool, design generator, code generator, document generator, database generator, error checking tool, security and version control, prototyping tool, screen and report generator. As an example, you can model a class diagram and generate code for the class diagram. Code can be generated in a programming language. Code can also be generated for a relational database management system. As an example, I can create a class diagram and generate data definition language statements for creating relations in Oracle. Case tools are computerized software development tools that support the developer when performing one or more phases of the software life cycle. It also supports maintenance, compilers, interactive debugging system, configuration management systems, and automated testing systems can be considered as case tools. Now let us discuss the types of case tools. Diagramming tools enable system process, data and control structures to be represented graphically. Computer display and report generators help prototype how systems look and feel. It makes it easier for the system analyst to identify data requirements and relationship. We are familiar what a prototype is. A prototype is a working model of the system. A prototype can be a throwaway prototype or an evolutionary prototype. Throwaway prototype, the prototype is developed, demonstrated to the clients and then discarded. evolutionary prototype is developed, demonstrated to the client, and requirements are added incrementally, and finally it serves as the end product. Analysis tools automatically check for important, inconsistent or incorrect specifications in diagrams, forms and reports. Central repository enables the integrated storage of specifications, diagrams, reports and project management information. Documentation generators produce technical and user documentation in standard formats. Code generators enable the automatic generation of program and database definition code directly from the design documents, diagrams, forms and reports. As I have mentioned, you can create a class diagram and generate code in a programming language, or create a class diagram and generate data definition language statements for a database management system. Case tools, classic versus real. Computerized software development support tools such as interactive debuggers, compilers and project progress control systems can be considered classic case tools. The tools that support the developer for a succession of several development phases of a development project are referred to as real case tools. When referring to real case tools, it is customary to distinguish between uppercase tools that support the analysis and design phases and lowercase tools that support the coding phase. Traditional development, software development lifecycle versus case tool assisted software development lifecycle. As we are aware, the major phases in the software development lifecycle are analysis phase, design phase, coding phase, testing phase, then the deployment phase and maintenance phase. Let us discuss traditional development, software development lifecycle and case tool assisted software development lifecycle. Customer requirements determination, identifying the correct functional requirements has an impact on delivering a quality assured software product. Requirements are identified, appropriate analysis is done. As an example, first a study of the existing system is done, the drawbacks of the existing system is identified, what will be the anticipated advantages of the proposed system will be listed out, a software requirement specification document will be prepared, which is mentioned as system requirement document. Once the analysis is complete, we enter into the design phase. As mentioned, we have architectural design and detailed design. In architectural design, we identify the modules and relationship among the modules. For each module, a detailed design will be prepared and the detailed design will be translated into code by a programmer or by a programming team. Once coding is complete, the module or set of modules will be tested. Testing can be done by the programmer or members from other teams or by an independent test group. Then the product is deployed. Once it is installed in the client side, the product enters into the operation and maintenance phase. When software development is done with the assistance of case tools, once the requirements document is prepared, analysis and design are performed using uppercase tools. Coding is carried out using lower case tool. Testing is carried out using case testing tools. Operation and maintenance are carried out using upper and lower case tools. Contributions of case tools to quality. Case tools support to developers. Case tools to improve software product quality. Case tools to improve software maintenance quality. Case tools to enhance project management. First, we will discuss case tools support to developers. Type of case tool: editing and diagramming support provided, editing text and diagrams, generating design diagrams to repository records. Repository query support provided, display of parts of the design text, charts, etc. Cross referencing queries and requirements tracing. Automated documentation, the support provided is automatic generation of requested documentation according to updated repository records. Design support, editing design recorded by the system analyst and management of the data dictionary. Code editing, compiling, interpreting or applying interactive debugging, code specific coding language or development. Code generation, transformation of design records into prototypes or application software compatible with a given software development language or development tools. Configuration management, management of design documents and software code versions, control of changes and software code. Reverse engineering, you have a legacy system which is operational for years together. Design documents may not be available, analysis may not, models may not be available. From the code you arrive at your analysis model. This is done using reverse engineering tools. Construction of a software repository and design documents based on the code. The legacy software systems, once the repository of legacy software is available, it can be updated and used to automatically generate new versions of the system. Project management and software metrics support progress control of software development projects by follow-up of schedules and calculation of productivity and defect metrics. So, in this slide we have discussed case tool support to developers, the type of case tool and the support provided. The types of case tools we discussed are editing and diagramming, repository query, automated documentation, design support, code editing, code generation, configuration management, reverse engineering and project management and software metrics. Now we will discuss the contribution of case tools to software product quality. The causes of software errors: classic case tools, real case tools. Causes of software errors: faulty requirements definition, classic case tools none, real case tools almost none. Client developer communication failures, classic case tools, none, real case tools, almost none. Deliberate deviations from software requirements, classic case tools, none, real case tools, high. Logical design errors, classic case tools, none, real case tools, high. Coding errors, classic case tools, very high, real case tools, very high. Non-compliance with coding and documentation instructions, classic case tools, limited, real case tools, very high. Shortcomings in the testing process, classic case tools, it is high, and in real case tools also it is high. User interface and procedural errors, in classic case tools it is high, and in real case tools it is limited. Documentation errors, in classic case tools it is limited, and in real case tools it is high. Contribution of case tools to software maintenance quality, corrective maintenance, adaptive maintenance, and functional improvement maintenance. Corrective maintenance, case generated full and updated documentation of the software enables easier and reliable identification of the cause for software failure. Cross-referenced queries enable identification of anticipated effects of any proposed correction. Correction by means of lower case tools provides automated coding with no expected coding errors. Adaptive maintenance, full and updated documentation of the software by the case tools enables through examination of possible software package adaptations for new users and applications. Functional improvement maintenance, use of the repository enables designers to assure consistency of new applications and improvements with existing software systems. Cross-referenced repository queries enable better planning of changes and additions. Changes and additions carried out by means of lowercase or integrated case tools enable automated coding. Contribution of case tools to improved software project management. Let us compare two projects of similar nature and magnitude. Project A is carried out by conventional methods, project B by advanced case tools. Method of development, planned resources, man-months. Project A, which uses conventional tools, 35. Project B, which uses case tools, 20. Actual resources invested, project A, 42. Project B, 27. Planned completion time, months, 15. Project B, it is 9. Actual completion time, 18. Project B, it is 12. It can be inferred that using case tools is much more economical than conventional methods. Categories of case tools, real case tools, upper case tools, which are also termed as front end tools, lower case tools, which are also termed as back end tools, and integrated case tools, workbenches, and other environments. Components of real case tools, upper case tools assist developer during requirements analysis and design workflows or activities. Lower case tools assist with implementation, testing, and maintenance workflows or activities. Integrated case tools provide support for the full life cycle. You can infer from this diagram, uppercase tools play a major role for planning, analysis and design. Lower case tools play a role for implementation, testing and maintenance. Workbenches, collection of tools that together support process workflows, for example requirements design, and one or two activities where an activity is a related collection of tasks. Commercial examples: Power Builder, software through pictures, software architect. Environments support the complete software process or at least a large portion of the software process. Normally include several different workbenches which are integrated in some way. Characteristics of a successful case tool: standard methodology, flexibility, strong integration, integration with testing software, support for reverse engineering and online help. Standard methodology: case tools must support a standard software development methodology and standard modeling techniques. Flexibility: flexibility in use of editors and other tools. Strong integration: case tools should be integrated to support all the stages. Integration with testing software: case tools must provide interfaces for automatic testing tools that take care of regression and other kinds of testing software. Support for reverse engineering: case tools must be able to generate complex models from already generated code. Online help: case tools must provide an online help tutorial. Pros and cons of case tools: advantages: produce systems with longer effective operational life and more flexible. Produce systems that more closely meet user needs and requirements. Produce system with excellent documentation. Produce system that needs less system support. Disadvantages: produce initial system that is more expensive to build and maintain. Require more extensive and accurate definitions of user requirements. Difficult to customize. Require training of maintenance staff. May be difficult to use with existing systems. Summary: case tools are set of software application programs which are used to automate software development lifecycle activities. Case tools are used by software project managers, analysts and engineers to develop software system. There are a number of case tools available to simplify various stages of the software development lifecycle. Example: analysis tools, design tools, project management tools. Use of case tools accelerates the development of project to produce desired result and help to uncover flaws before moving ahead with next stage in software development. I acknowledge the authors of the books which I have referred and the web resources I used for this presentation. Thank you.